Hey guys, so I'm starting the build of the Tomoquads Tiny Swift, and I wanted to go over all the parts I'll be using. Um, these are the parts over here on the right that came with the kit itself, and then these are the electronics here on the left that I'll be using that are not included with the kit. I'm using the Racer Star 1103 10,000 kV motors, the Emax Femto flight controller, the Racer Star 6 amp 4-in-1 ESC, that's the version 2. Here on the right are all the parts that come with the kit itself. There's a prop cutter here that you can use if you tie on a nail cutter, and then they sent this other prop cutter as well. This is also 3D printed. You stick your 4-bladed prop in here. It's meant for like a Racer Star 2030. You cut it down to 40 millimeters, which is what this is for. Now these are the other parts here. These are this is the carbon fiber parts. This is the prop guard. You got the main plate. You got a couple of smaller carbon fiber plates here. I think this one here protects the bottom on the ESC side. You got some nylon parts here, some nuts, some nylon long screws, and then these here are some metal self-tapping screws that hold the 3D printed parts to the carbon frame. There's two sets of 3D printed parts that I got. The ones here in white are in nylon, and these here are in yellow. The neon yellow are TPU, and this bright yellow is ABS. And I think that there's a difference in the weight, so I'm going to go ahead and measure that, but I'm going to measure it without this part here. This is the normal camera mount that goes on the very top, and this is the receiver sits in the back here, but I'll be using these instead. This is the E-Sheen, I guess the Canopy or whatever. We'll see later. I don't have it on the table here, but there's like a little small clear canopy that goes on top. It's actually meant for the tiny whoops, and you can put it mounts the camera, and then you can stick the receiver in the back here. So I'll be using this one instead of that one. And so I'll weigh these two separately without this part here to show you what the difference is in the weight. I'm not sure if it's going to be a lot, but let's take a look. Okay, so these are the TPU and ABS parts, and they come to 6.44 grams. Okay, and these are the white nylon and white TPU parts that come at 5.76 grams. So I'll go ahead, I'll use the white nylon parts for the initial build. I may use the TPU parts later. Okay, so when you start building the Tiny Swift, it's kind of like a pretty complicated jigsaw puzzle. You want to start with this piece first. This is the very bottom piece. We're going to start from the bottom and go up. And you want to start with these 4 long nylon screws. This is the bottom because it's going to be protecting the ESCs. And you want to make sure that the little connector here is in this notch for the ESC so that it'll come out here. And you're going to use these little spacers, these little TPU spacers in here, like so. And you run these nylon screws up through the bottom. Put your ESCs in top like so. So it should look something like this. You have the spacers between this little bottom plate and the ESCs, and this little notch here is going to be where this connector is. It'll look like that. I'm going to add this other spacer on top of that. Okay, so at this point, the stack should look like this, and just for orientation, this part right here should be in the front, I believe, and the connector should be in the back where the battery lead is. And I've on the 6 amp 4-in-1 AC, I've already replaced these wires that were on there with a JST connector that came with the Femto, and some additional wires here that's going to go to the Femto to power it. So I'm going to solder that onto the Femto a little bit later. Okay, this way you want to put the main plate on top, and as I mentioned before, this is going to be the front, and on the main plate there's only 3 screw holes that go to the front because the rear part here doesn't have a screw. That's where the USB port's going to be for the femto. That's why there's only 3. It's going to go like this. So at this point it should look like this. And then we're going to use the double-sided foam tape that came with the femto. We're going to stick that in here. And then put the femto in. And I've already pre-soldered my pigtails for my video transmitter, camera combo, and my receiver. And we want the USB port to go out the back. And that's going to be this one right here. And so we're going to actually screw on the nut for this one here and cut off this nylon screw because we're not going to be using the rest of this screw anymore. And then the femto is going to go in here like so. So I'm going to go ahead and do that and I'll be right back. Okay, so here's what it looks like at this point with the femto mounted with the double-sided foam tape. And you want to definitely use the foam tape to minimize vibrations because the femto has the 9250 gyro and it's more sensitive to vibrations from the frame, so definitely use that. And then the next part will be using this additional spacer here that goes upside down and goes on the remaining 3 nylon screws. I cut off this one over here already. I'm going to put this one on, and then we're going to, I believe the next part is to put on the prop guards. Put this one on, and then probably put the motors on, and then solder the motor wires to the ESCs. Let's see what else. Got to solder the ESC signal wires to each of the 4 corners for each motor, and then we can put this piece on. Okay guys, so I spent like about 2 hours installing the motors and wiring them up to the ESCs and to the flight controller, and I would have to say this is probably one of the more difficult builds out there. If you're a beginner, I recommend staying away from this. This is pretty hard to build. Now, once I mounted the motors, I ran the wires through this hole here underneath and then soldered them to the ESCs. Now as you see, these are numbered in Betaflight as motors 1, 2, 3, and 4, and because of the orientation of the ESC being at a 45-degree angle, I decided just to wire them directly to the appropriate number. So here's motor 1. This is going to ESC 1. You can see A1, B1 there, and I think that's 2. And then 3 and 4 are swapped. Normally 3 would be down there and 4 would be up top. So I just wired them directly to the appropriate ESC. So there's motor 4, and this is going to ESC 4. So it just makes the wiring a lot more simple. Using these 4 signals here. Green is 1 and orange is 4. And just routing them up to the flight controller. And make note that because the USB port is now pointing out the back, you need to rotate the board 90 degrees, but you still want to put the signals in the correct spots. So here's a signal 1 for motor 1, motor 2, motor 3 is over here, and motor 4 is over there. So that's how you would wire it up. If you've done a lot of these builds, you'll probably be able to look at this and figure out what's going on. These are my pigtails for the receiver and all-in-one FPV camera. This is that one other part, that's the extra spacers here, and I have that one screw in the back here screwed down with this nut. The USB port's still accessible, but yeah, this is what it looks like. And if you guys look at this. You should be able to figure it out if you're a seasoned builder. If you're a beginner, as I said before, I'd recommend not building this because probably say wait for the Ishin, what is it, the Aurora 68 that's coming out. It's about this size, and you don't have to build it, so keep that in mind. So the next part's going to be sticking on this part here. So you want to screw in these 3 screws to this piece here, and then this is going to go like so. And then we're going to use the nuts to screw these down and cut off the excess screw there. And then this is basically where the prop guard attaches to. These 3 holes here will attach to these. Let's turn this here. These 3 holes over here, like so. And then the camera mount will be on top of this. And then you can kind of see how it's going to come together once you put the props in. And it should all work out. So I'm going to just go ahead and finish building this out, and then I'll show you what it looks like at the end. Okay, so here's a quick look at what it looks like before I screw the canopy on, and it just goes into these 3 points here. I use these 2 silver screws, and these are Allen wrench screws, to secure this mounting plate on top. You have your pigtails coming through the center hole here in that middle piece. And just have my receiver here. I'm going to just use some double-sided foam tape, stick that on, screw down the canopy, and I should be ready for a hover test at that point. So let me screw that on, and I'll show you what this looks like completely finished. Okay, so here it is with the canopy mounted. You can see here I just used 2 screws on each side to mount the canopy, and there's enough space underneath it. You can see that there's the receiver right there, and plenty of room for extra wire for that connector there for the all-in-one FPV camera. Now I was using some 4-bladed Furious FPV props before, and I tried to hover test and it was vibrating horribly, so I thought maybe the props were unbalanced. So I switched to these Cheerson CX31 props, and the vibrations were a little bit better, but still pretty bad. So I'm going to have to go into Betaflight Configurator and make some modifications to the tuning and the filtering to get rid of these vibrations. They're coming from the Emax Femto, the 9250 gyro, which is really sensitive to vibrations, and in a small frame like this, and really fast motors, these vibrations are just going to get wildly exaggerated, which causes the whole thing to shake due to D-term oscillation. So I'll try and figure that out in the next part of the video and show you a little bit of how I set this up in Betaflight Configurator. Now, comparing this to one of my Tiny Whip builds, this is what it looks like. So it's a little bit bigger, obviously, and it's going to be quite a bit heavier, but you can see the same type of canopy here and same type of camera is being used. And with the battery at the bottom there, it's going to be quite a bit taller. Maybe some a weight measurement of this guy. This is without the battery, and it's coming in at about 43.9, 44 grams on the nose. So the battery I'm planning to use is this one. It's the Turnigy Nanotech 300 milliamp hour 2S 45 to 90C, and this weighs about 16 to 17 grams. I would rather have something maybe smaller or thinner, but I don't have anything on hand at the time, so I'm going to just be using this for now. It should fly just fine. Okay, so these are the settings that I'm using for the Femto flight controller. I flashed it with Betaflight 3.1.6, and here are all my settings. You have to enable UART3 for the receiver. In this case, I'm using the FlySky FS-A8S receiver, and I'm using it on iBus. Here's my config for the demo flights. I'm using OneShot 125, And you can do a D-shot on these 6-amp ESCs, but you have to rewire the flight controller, and I didn't feel like doing that, so I think 1-shot 125 is adequate for this setup. And under the board alignment, you got to make sure your yaw is turned 90 degrees, otherwise it'll flip out on you. And as before I mentioned, serial receiver on iBus. On the gyro and PID loop frequency, I'm going with 4 and 2 because the vibrations from the gyro affect the flight a lot, so I'm trying to keep these as low as possible. I'm flying with the accelerometer on. I have my failsafe set. You always check your failsafe to make sure that it's functioning properly, with the props off, of course. Here are my PIDs. Now, take these PIDs with a grain of salt. If you don't have the exact same parts that I do, then these PIDs probably won't work. All of these rates are, or all of these gains are a lot lower than I typically fly for these micros because of, again, the Femto gyro, the 9250 is very vibration sensitive, so and if you have really high gains, especially on the D gains, you're going to get a lot of D-term oscillations, and I was getting that initially on the first hovers, so I had to bring all these down. And additionally, you have to go into the filter settings here, and I brought these numbers all the way down. The gyro soft low pass down to 50, and the D-term low pass down to 30. And so these are pretty low numbers. It does make the craft feel a little unresponsive, especially in sharp turns. But there's nothing you can do about that, because if you have these higher up, there's so much vibration that all you get is jello in the video. So keep that in mind. These are the numbers that I'm using. Nothing special going on here. I just have my mode set up here on aux1 and aux2 for arming and for angle and acro mode. I use this for my in-flight adjustments. And that's about it for the setup for Betaflight. I'll do a CLI dump, and I'll put that link in the description if you guys want to check that out. But again, if you don't have the exact same parts and props and everything, it won't fly the same. Just keep that in mind.